Welcome to the next lesson on stoichiometry, looking at the amount of excess reactant and the amount of product formed. You should be coming here directly from the previous lesson on limiting reactants. So in this lesson, we're going to find out exactly what the amount of excess reactant does for us. So in this lesson, we're going to find that we're going to need to use a mass-to-mass calculation with that limiting reactant as our given. You're going to have to make up this problem on your own because it's never going to be given to you exactly as the wording. But the limiting reactant now is going to control, as I said before, is going to control everything about the reaction. So it becomes our given in this situation, and then we're going to look for the amount of the excess reactant used. So we want to know how much is used. And this is just like any other problem we've done before where we looked at one reactant to another. We're going to look for the amount of reactant used. And then once we find out how much is used, we're going to subtract that amount from the amount that you're given to find the amount of the limiting reactant remaining. To find out how much product is formed, again, you're going to start with that limiting reactant as you're given. But now your wanted is going to be the amount of product formed. And this should be fairly familiar as a calculation. Again, things we've seen before. Let's start off with a mole-based problem to begin with, so that it's easier. So in the previous lesson, we saw that nitrogen was a limiting reactant when we had this set up. And so what we're going to ask is two things. First of all, how much of the excess reactant, the hydrogen now you know, remained, and how much ammonia is produced. First thing we're going to do is we're going to start with the number of moles of the nitrogen. Don't go back to grams. You already calculated the number of moles of nitrogen, so start from there. We're going to start with the number of moles of nitrogen, and we're going to then take that implied 1 here. That's going to go in the denominator, and we're going to take the 3 here in front of the hydrogen, the coefficient, and that's going to become the mole ratio. So we're going to have 3 moles of hydrogen over 1 mole of nitrogen, and the moles of nitrogen are going to cancel out with each other, leaving us with moles of hydrogen. We're going to multiply by, we're not going to multiply. We're just looking for the moles, so it's going to be 6.9 moles of hydrogen gas used. We're going to do a very similar thing to find the amount, before we do that, we're going to figure out how much hydrogen is left over. So this is how many moles of hydrogen gas are used. What we want to know is how much is left over, and so we're going to subtract that 6.9 moles from the 7.6 moles of hydrogen that was available, and we're going to find that we have 0.7 moles of hydrogen remaining. If you get to this step and you get a negative number, it means you probably chose the wrong limiting reactant, and go back and check your work to make sure you get this correct. All right, so next part of the question, how much ammonia is going to be produced? So we're going to start again with our 2.3 moles of nitrogen, but now the ratio is going to be the 2 moles of ammonia, because that's what we're looking for, divided by the 1 mole of nitrogen, and the moles of nitrogen cancel off, and they leave us with 4.6 moles of ammonia formed. All right, so this is a very easy mole-to-mole problem. Let's make it a little more difficult. Again, going back to the previous lesson when we had the 20 grams of nitrogen and 10 grams of hydrogen, we want to know how much hydrogen remains because we've identified that nitrogen was a limiting reactant, and we want to know how much ammonia is formed. Again, since we already know the moles, don't go back to the mass. Don't go back to mass. So we have 0.714 moles of nitrogen. Let's multiply that by our mole ratio so that the moles of nitrogen cancel, and we have 3 moles of hydrogen. Now we are going to go on to the molar mass of hydrogen. The molar mass of hydrogen, so the moles of hydrogen cancel out. Moles of hydrogen cancel, they leave us with grams of hydrogen, and we have 4.32 grams of hydrogen are used. But that's not the end of it. We want to know how much hydrogen is remaining, so we start with the 10 grams of hydrogen that we were given, subtract the 4.32 grams of hydrogen that was used, and to significant figures, we have 5.68 grams of hydrogen remaining. Continuing on, we're going to determine the mass of the ammonia formed. Start again with the 0.714 moles of nitrogen. We're going to multiply by 2 moles of ammonia over 1 mole of nitrogen. We're going to multiply by 17.04 grams of ammonia in 1 mole. And let's see what cancels here. Moles of nitrogen cancel with moles of nitrogen. Moles of ammonia cancels with moles of ammonia. We're left with 24.3 grams of ammonia formed. Think you're ready to go? Again, going back to that last lesson, when we had 84.9 grams of iron 2 sulfide and 64.9 grams of oxygen, we found that the FeS was limiting. So your job is to figure out how many grams of oxygen remain and how many grams of the iron 3 oxide are formed. I'll pause the video, restart it when you're ready to go. And we're back. So let's see how you did. First thing, we know we want to start with the moles of the FeS. You determined the moles before, so don't go back all the way to the mass. You don't have to do that, but we are going to go all the way to the mass of the oxygen. We're going to multiply by the 7 moles of oxygen and over 4 moles of FeS. And we're going to cancel out there. Cancel out the moles of the FeS. We have 7 moles of oxygen multiplied by the molar mass of the oxygen, and the moles of oxygen cancel out. And that leaves us with 54.1 grams of oxygen used. But as before, this isn't the end of the problem. Now we're going to take the starting amount of oxygen, subtract off the 54.1 grams of oxygen that was used, and we're going to end up with 10.8 grams of oxygen remaining. Continuing on for the product, the mass of the Fe2O3 is going to start with the limiting reactant. We're going to multiply by the mole ratio, cancel out the moles of the FeS, and we have 2 moles of iron on the top, iron 3 oxide, sorry. Multiply by the molar mass of the iron 3 oxide, cross off the the moles of the Fe2O3, and you should have gotten 77.1 grams of Fe2O3 formed. Hope you did well on this lesson. Now I'll see you in class for the next mastery.